Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. The link is in the show notes. This podcast is brought to you by Jarhead Diagnostics. Jarhead Diagnostics manufactures in-house diagnostic equipment and storage solutions, as well as distributes for companies like Pico, ATS, and TopDon. One of my favorite tools that I've bought from Brandon and Jarhead Diag is the case for the U-scope. If you don't have a U-scope, you probably should, but if you have one, you got to get one of these 3D printed cases, has a magnet on it, has a full-size BNC lead that you can connect to, and it gets rid of the weak point of that scope, which is the mini BNC connection, which is pretty fragile. This case makes this thing nice and secure and makes it an even better tool than it was. So check out jarheaddiag.com. The link is in the show notes. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host today, and I've got another case study for you today. This one's pretty interesting, or at least I thought so. I'm working on a 2013 Toyota Sienna today or last week, and the issue that I was having with this, or the shop was having with it, and why they called me in, was the HVAC system does not work. Specifically, the door positions don't seem to change. Even more specifically, the mode function, right? Where the air leaves the dash doesn't seem to change at all. And that's the customer's main concern. That's what the shop's been after. So we'll get into this here. What I ended up finding, I thought, was pretty interesting. But before we jump into that, I did want to remind everyone that we're doing a giveaway here, and we're going to do this on a monthly basis. So it'll be ongoing, at least for the foreseeable future. But we do have some t-shirts and sweatshirts available. If you want to purchase one, get a hold of us on the Facebook page or through the email. You can find those in the show notes. But we're going to be giving away some free t-shirts. We'll announce it live on the podcast. So we'll do this every month. And all you have to do to enter to win is leave a review on Apple Podcasts or leave a comment on one of the videos on our YouTube channel. And we do have a YouTube channel, and making people aware of that. Of all the episodes are actually up there, but we've just recently, in the last few months, started doing video, both for the case studies and for the interviews. So if you want a visual guide to go along with what we're going through on the podcast, it's there. I still make these so that you can listen to them audio only, and just got to use your imagination a little bit. And I do my best to explain things, which isn't always the easiest, but I do my best to explain things so that you can picture it in your head without actually seeing it. But if you wanted some visuals and some pictures from the vehicle I'm working on, there will be for the case studies, a PowerPoint that goes along with the case study I'm explaining verbally. For the interviews, we'll have a video of the people talking. So anyways, check out YouTube if you want to, but to win that free t-shirt, just enter by putting a comment on a YouTube channel or leaving a review for the podcast on Apple, and we'll enter your name into the drawing. And what we'll do is we'll announce it live, well, not live, but on the podcast. And if you hear your name, get a hold of us, we'll get the shirt shipped out to you. All right, cool. So with that out of the way, let's jump into this. Again, this is a 2013 Toyota Sienna, has automatic HVAC, right? You just pick the temperature. It's going to use a variety of inputs to determine the airflow, the air direction, the temperature, the AC function, heater, all that stuff, to get the temperature in the cabinet where you want it. The original complaint that the customer brought the vehicle in was that the mode settings were not responding correctly. All the air always seemed to come out of the defrost, the up at the windshield. That's where the air was leaving. They weren't able to replace it. Now, the shop had replaced a number of components on this to try to get this functional, and they had already been in this quite a bit before they called me with a lot of part replacements, which can make things difficult at times because I don't know, am I chasing the original problem or a built-in problem? Maybe both, right? But here's what they replaced. They replaced the mode door actuator, right? It's an electric motor that moves a door in the HVAC housing under the dash. And just as a note, this actually comes with the passenger side blend door actuator. When you buy these, you get both motors, and it's kind of an assembly that you bolt to the right side of the HVAC housing. They also tried replacing the control head, which is the buttons on the dash that you're actually pressing to select mode, fan speed, temperature, all that stuff. And they replaced the AC amplifier, which I'll explain its function in a little bit. And they told me they did this all with OE Toyota parts. They did not use aftermarket anything. And now he said they were all new. I assume he got them from the dealer, but that's what I was told when I got into this. So there was no change in operation. None of that changed anything, fixed anything. And so this is where they call me, because they don't seem to be making any headway on this. And they also did mention that they have a persistent trouble code in the AC amplifier, which is a B1497. And he actually the tech who called me texted me this code. Said, do you know what this means? I'm like, I'd have to look at it. I don't know exactly, what to tell you just by looking at the code. So anyways, that's why I'm there. Well, let's figure this thing out. And again, try to determine what exactly I'm dealing with here. So I get into the vehicle, full vehicle scan, right? I do have that code in the AC amplifier that they mentioned, the B1497. And I verified that the symptoms are exactly what they're talking about. Can't move the mode, and it doesn't seem to respond much of anything, right? Like you can feel the air coming out of the vents and change the settings, and sometimes you can hear some stuff happening in the dash, on a vehicle, right, that's functioning. You could hear the door moving. I don't hear any of that. I don't feel any difference in the airflow. Doesn't seem to be moving on the mode setting. At first I didn't run it long enough to get it hot enough for heat, but at this point I'm really focused on the mode, and we'll see where we go from there. But anyways, I go through the scan tool in the AC amplifier, which is the control module for the HVAC functions. And I do see an initialization in there. And so I just ran that. Sometimes I just hit buttons and see what happens. I'm really not into the diagnosis very far. I'm just sitting in the driver's seat doing my initial assessment, but I see an initialization process in there, and I run it and it doesn't change anything. Okay, well, maybe I'm doing it wrong. I'm not set up correctly, other problems, whatever, but I just figured I'd try. Anyways, that didn't do anything. And as I'm looking at this, I do realize, well, I'm not entirely familiar with the system operation or setup for the Sienna. I mean, how complicated can it be? It's just a regular, it's a regular HVAC system. It's got electric motors that are going to move doors to different positions and a control head that's in charge of them. Okay, but I want to know the details. And I also want to know the details on this 1497, this code that I have in the amplifier. And I cleared that and it came back immediately. First key cycle, it's right back. And so this is a hard fault right now. So I want to know about the code, and I do want to know about the system as well. All the details on what's going on. So just a real basic overview of this system, so you have an understanding of what's going on here. We have the AC control head on the dash, which is your control panel. It's got the buttons. And really, that is just going to take inputs from the driver of the vehicle or passenger of the vehicle. And it's over a LIN bus. It's going to send that information to the AC amplifier. So the AC amplifier is really just your HVAC control module. And this is the module that's in charge of actually doing everything in the HVAC system, right? It's going to send the actual commands to these motors to move to certain positions, and the rest of the system, blower, motor, compressor, and all that stuff. Obviously, the engine control module is involved with that. I'm not so worried about the compressor at the moment, but our AC amplifier is the control module for the HVAC system. It's where all the decisions are made on what's going to happen and where things are going to move. And that's also the control module that I am connected to with a scan tool that's reading out this 1497 code. Now, off of the AC amplifier, and it's got a bunch of circuits, but the ones I'm kind of focused on here, concerned about, is it's connected to 4 different actuators that move doors, right? You've got, it's a dual zone setup for the climate. And I think there was a rear HVAC system in this one as well. Honestly, I didn't even look at that because they weren't concerned about that. They were concerned about the front, and we're really just going to be focused on the front here today anyways. But it's got 4 electric motors that are going to move doors, and it's dual zone. So you have a driver's side blend door actuator, which moves the door for the temperature for the driver's side of the cabin. And then you have a passenger side blend door, controls the temperature for the passenger side. And then you have a mode door actuator that's going to move a door, and it will change where the air exits the dash, floor, panel, defrost, combination thereof. And that's the one in question. And then also the recirculate door, right? So 4 total motors, and off of the AC amplifier, we've got 3 circuits that look like they run to all of these motors, right? So you actually just have 3 wires, not total, but for these circuits, you have 3 wires that leave the AC amplifier and then branch off to these 4 motors. And they're all wired in like a bus style based on the diagram, right? So you have 1 red wire that's power that goes to all 4 of these. You got 1 black wire that's ground, and then you have 1 blue wire, which is a LIN bus that goes to all 4 of these motors. So these motors are actually functioning on a LIN bus from the AC amplifier. So I get this from the system description operation. I'm like, okay, well, this should be fairly straightforward to figure out what's going on here. As far as the physical location of parts go, there is the driver's side blend door is on the left side of the HVAC housing, which is kind of centralized under the dash. Over on the passenger side, behind the glove box area, you have the passenger side blend door, and you have the mode door actuator, which are actually in assembly. You get those 2 together and you replace them together. You also have the recirculate door over on the passenger side, and the AC amplifier that's all behind the glove box. So they actually had the glove box area open, exposed, so I could get to all these components, which was nice, but that's kind of where everything is on the system, just so you can imagine. The code that's in there, the B1497, I want to know a little bit about that as well. This is in the AC amplifier, and the title of this is Bus IC Communication Malfunction. So this is a communication code. And what it says in service information is that the communication line has an error or it's open. Okay, so maybe we're dealing with a LIN bus issue here. Sure sounds that way. For the possibilities for causing this code, it gives you a lot of options. It says air conditioning harness. It mentions the rear system as well, but again, I'm not focused on that because our front system's not the one that's not working. It says basically any of the servo motors or the actuators could be causing this, any one of the 4, or the rear, or the amplifier, or again, it lists the harness or connector. So really anything in the system could be causing this, the amplifier, the actuators, the harness. So we're probably going to have to do some testing to narrow that down. And if you go through the flow chart, it's honestly pretty basic in what it has you do. It has you go in to the active test function of the scan tool and attempt to operate each door and replace any door that doesn't move correctly. That's it. You go in, you try to move it. If it doesn't move to where you want it to go, you replace that mode actuator. That's it. If you have this code, it doesn't have you do any circuit testing. It just has you replace it. And the shop kind of already did that, right? They already replaced the one that was not moving correctly. And then it says if replacing the door doesn't fix it, they say to replace the harness. That's the next step. Now the shop didn't do this, but they say if the harness doesn't fix it, then to replace the amplifier. The shop did replace the amplifier. So do we just need to throw a harness at this thing and we'll be done? Maybe, who knows? But I would like to do a little bit of testing before we throw more parts at it. Again, I don't know if we're still dealing with the exact original problem or if we built some stuff in along the way. I've got to do some testing to determine that. So I do what it says just because I want to see what's going on here. And I run the active test through the scan tool, right? Which is commanding the motors to move to a specific position. Now, what I find is the mode door position does not change, does not respond, but neither does the passenger temp door position. Those don't seem to move when I command them in the scan tool. And again, the shop already replaced the control head. The original one is installed right now. They said they put the original one back in because it didn't do anything. They replaced the amplifier, and I was wondering about programming, but they're like the original one's back in now. Okay. Maybe we'll put the new one in and see what happens. And they replaced the mode and passenger temp doors. The new one is installed right now. They said these things were a really big pain to get out, and you're supposed to pull a dash. They said they snuck it in without pulling a dash, but it's a huge pain. So the new motors are in for the mode door and the passenger temp. They said this didn't change anything before and after. Okay. But again, I'm wondering if I'm fighting a man-made issue or original problem. So when I'm doing this testing on the motors, I can't get those two to move. And if you look on the scan tool, it's going to show you pulses, right? Because these are servo motors, and they're going to pulse the motor to move it to a specific position, like a stepper motor style. And the limits on the scan tool go from 0 to 255. Looking at some good ones like the passenger temperature or the recirculate, I see that most of them are under 200 and they move to where you command it to. Now, the mode door on the passenger side there, that's always at 255 no matter what I do. The passenger temp was at about 50 and it moves just slightly when you command it, but not to the correct position. So something's interesting here. The mode door definitely seems to stand out as something's wrong. Like 255 is the absolute limit. So what does that mean? Is it way out to lunch as far as the position goes? Or is this where my communication issue is, right? And again, we want to understand that code. There's not much that they give you. At this point, I would be replacing that motor based on the code. But is that 255 representative of that unit, that mode door not being able to communicate over the LIN bus to the AC amplifier? I don't know at this point, but it definitely seems to stand out. But I see an issue with the passenger side temp as well. And again, remember those two components are kind of the same unit, two different motors, but they bolt onto the side of the HVAC housing together. And if you're looking at the YouTube video, there's a picture behind the glove box. So you can kind of see them. They're kind of squeezed in there. It's tough to see. I did notice the harness that goes to these, right? It kind of daisy chains off of itself to go to each one. And it has different colors on the harness depending on which motor that it goes to, which I thought was interesting. And looking at the wiring diagram, it actually tells you which color is which. And I did verify, okay, hey, the right color for this connector, like the connector has a little, I don't know, just a cover over the connector, and it's colored. And I matched it up to make sure they went to the right ones, and they did. Okay. Now, again, the shop already replaced these. These are new parts. He said he got them from the dealer. but there is quite a bit of complexity to the arms and gears that when you install these, you have to have them timed correctly. And I'm wondering, I'm like, I don't, who knows if they did this correctly or not. I've never done it myself, but it looks complex. And talking to some people later, I guess it is a really big pain in the ass to do these, especially if you're not pulling the dash out. So I am suspicious of the install on this. Just because they're new didn't mean it go incorrect. Now, would that set my communication code? And why does it read 255? And why isn't the passenger side moving? I don't know any of this stuff yet. So again, I got to come up with some tests to do to really make a determination here because I don't want to take this thing apart. It does look like a pain. And I want to be confident if I tell them they've got to take it back apart because it sounded like they didn't really want to do that. Um, I did a visual inspection here while I was commanding these. So I can see what's on the scan tool, but I want to see what's happening on the car. When I do this and I command the mode door, nothing happens, no movement. It's completely dead. I don't see anything. And I can kind of see the arms that are connected to it. There's no movement at all. The passenger side actually looks like it tries to move, but it almost looks like it's bound up. So we have an attempt on the passenger side blend door, but nothing on the mode door actuator. That's my visual inspection for that one. The shop does have the original motors still at the vehicle there, right? They've done some component swapping. And so what I did here was I unplugged both of these that are in question, the blend door for the passenger side and the mode door, and I plug in the original motors just to see what would happen. Do I still have my communication code? Do I still have that issue? Do the motors move if I do the active test or cycle the key? And what I found was I actually had to power cycle the module to get this to happen, but I could see the passenger side blend door motor moving. Now, keep in mind, this is disconnected from the car. I just got the motors hanging there, and these are the original ones. The passenger side blend door moves, it rotates. The mode door does not, and I still get my same code, that B1497. I think I got a code for the passenger at this point too. I actually don't remember, but I know that I still had my 1497 code, communication code set, and no movement from the mode door. All right, I've got to do some circuit testing here because it just seems like I'm not sure on the passenger. It almost seems like something's wrong with the door or the install, but the mode door is kind of throwing me off. Like there's no movement at all from either motor, and I have a communication code. I've really got to look closer at the circuitry to see is there something up with the LIN bus, and that's kind of what I was thinking. And I'm also curious at this point on how the control module knows which motor is which. Are these unique part numbers or can the motors be swapped? And I did look at the part number on the actuator. It was the same as the one that was in the mode door position. So the same part number doesn't mean it's right, but they said they got it from the dealer and they installed it that way. But I'm not really sure on how the AC amplifier knows which motor is which. Maybe the unit has some sort of identifier and can say, hey, I'm the mode door out on this LIN bus. But I really wasn't 100% sure on that. And that's what I'm wondering, like, did some motors get swapped around here and we don't have the right one in the mode door position? But we'll continue on. It was just a thought that I had at this point that I didn't have an answer to. So I checked for power, ground, and LIN at the connector for the mode door. Now I can't back probe these connectors, and there'll be a picture on the YouTube video, but the way the connectors are, again, they're kind of like daisy chained to one another, and there's really no place to back probe them. But I pierced the wires. It's under a dash, so I'm not really worried about, uh, exposing the wire to corrosion or anything like that. But I pierced the wire right at the connector, and I gave them a little bit of a tug to make sure there wasn't like a open inside the connector. They're all tight there. I've got power, I've got ground, and I've got LIN. Everything looks good right at the mode door connector. And I tried unplugging various motors on that bus to see if anything happened to the LIN bus while I'm watching it on the scope. Like, is there one of these motors that's corrupting the LIN bus somehow, causing my communication code? I don't know. Again, when I unplug everything, nothing really seems to change. It's just a normal LIN bus waveform, and I've got it right there at my mode door, which doesn't seem to be doing anything. And so I also pin drag tested the connector at the mode door. Now, this was strange because there was 5 pins that all seemed to be occupied on this mode door, but there's only 3 wires going to it, a power ground and a LIN. And honestly, I didn't think much of that at this point. I just sort of breezed right over it, but I did notice it. I was like, huh, there's 5 pins here. There's only 3 wires going to it. But there is a clue here. Had I paid a little bit more attention, might have gotten me to the answer sooner, but I just kind of glanced over that there was 5 pins, but only 3 wires. So anyways, but the pin drag test passed okay. So I know I'm making contact with the pins on the actual mode door. So I'm kind of recapping here is that I'm suspicious of the install, and that might explain the passenger side temp door issue. Like something's bound up, something's not moving, it's not timed properly, but it doesn't explain the mode door. That no movement and the communication just don't seem to add up to improper install. Maybe it's the wrong part. I don't know. And I got with the tech at this point and I asked him about the timing of the gears and the arms and the movement of the doors. Did you check to make sure everything was moving freely? He's like, I did. I checked all that. He was pretty confident that he installed everything correctly. And he mentioned that it's a pain to disassemble. He doesn't want to do that unless I'm sure. I'm like, I get it, man. I don't want to send you on a wild goose chase either. That's no fun. So this is kind of a tough one because sometimes I'm not very afraid to tell people to take stuff back apart. In this case, I just wasn't 100% sure. And at this point, I've summarized this relatively quickly, but I had an hour into this already at this point, and I don't necessarily have a good direction. And I was kind of busy. I had to get on with my day. And sometimes on a system like this, where I just don't feel the confidence or the familiarity with the system, I'll tell them, hey guys, I'm gonna come back. I'm gonna leave to the rest of my day, research this, talk to some people, get some more info. I will come back and revisit this. And we'll try to make a determination because I don't feel confident sending you back in, taking stuff apart when it's going to be a pain in the ass, right? That's my decision, and sometimes I'll do that. And I would say most of the time that is the best decision even if I don't get the greatest information that I'm looking for, sometimes just walking away from something, coming back to it, you have a fresh perspective, or you think about something while you're driving that, like, oh, hey, why didn't I check that? Or why didn't I do this? Or, whatever. But then sometimes you do get some good information from reading or from talking to people. And credit to PJ Walter. I did talk to some people on this. He's a Toyota guy. He actually really sent me in the right direction on this one. Um, he suggested that I look inside of the motor connectors. He said they're basically like a Scotch lock style connector where the wires lay across in this connector and the little cover that goes on top of them, the clip that goes on top of them, presses the wire into these little metal teeth and pierces the insulation so that the wire can make contact with the connector. And that's why I really couldn't back probe these is the way these are. Think of it like a Scotch lock connector. If you've never seen one, Google one. You'll see some DIYers install those from time to time. But it's basically exposing the wire to the elements, and it's really not the greatest connection to a wire either. Anyways, that's the style that these use. And he said it's common to get corrosion inside of these connectors. So you need to pull the little cover off of the connector and look for corrosion. Okay. So when I went back, I did this. I went back, it was a couple days later, but I went back and that was the first thing I did was I went to the connector at the mode door and I pulled a little cover off of it to see, hey, do I have any corrosion in here? And I didn't. It actually looked pretty clean. And if you look at the picture on the YouTube video, I'll put this in the Facebook group as well. If you don't watch the video, I do want you to see these connectors. They're pretty crazy. It looks pretty clean, but I am wondering, okay, well, maybe there is a contact issue. Let me try testing on the pins, right? And I mentioned there was 5 pins, but only 3 wires going in. So I take my scope, I have the car on, I have the little cover off of this side of the connector where I can see the wires being jammed down into these little metal teeth. And so I go into each pin testing for, I'm looking for a LIN bus here, really, and I don't see anything. And I'm like, oh, that's weird. And I also don't see any power, and I also don't see any ground. I'm like, there's nothing on any 5 of these because all 5 were occupied with metal female terminals on this connector. I don't see anything. And I test on the metal teeth and I see the power, I see the ground, I see the LIN bus. I'm like, well, that's weird. So I flip this connector over and there's a cover on the other side of the connector as well. So if you imagine this little blue connector, it's got 5 pins, 3 wires going into it, a cover on both sides, just a little plastic clip that you can take a pocket screwdriver and unclip it and expose the inside of this connector. Well, on the flip side of this connector, if you open it up, it is not just a connector. This actually has a printed circuit board inside of the connector with a little capacitor and resistors and an IC driver in the connector itself. It's essentially a little module inside of this connector. And when I open this up and you can see the picture on the YouTube video or on the Facebook group, this thing's all full of corrosion. And I don't know if it's water or if the capacitor actually leaked out of this one, but something corroded this board like crazy and caused it to not function. And this makes total sense. This is how the computer knows which motor is which, right? And that's why the connector's colored, because it goes to a specific motor and it has information in there to say, hey, I'm the mode door connector. And I'm going to take the data from the LIN bus that the AC amplifier is sending out, and I'm going to change the motor position based on that. And because it's a 5 wire connector, it's got 2 for the motor, 3 for a potentiometer. I'm going to feed back position or pulses out onto that LIN bus for the AC amplifier. So that's all happening within a connector, not the motor itself, but the connector that plugs into it. So this harness has 4 little tiny modules, one at each connector in them. And I had no clue. I've never seen anything like that before. And this is a 2013. It's not even that new of a vehicle, right? This 10 years old, and they're putting modules inside of the connectors, which is pretty crazy. Now, reading service information, when I went back over this and was making my notes for the podcast, I did find that they laid this out in service information and I breezed over it. I did not read closely enough. I didn't read everything line by line, and that's on me, right? You got to read. As obvious as that sounds, and everybody says all the time, read service info, read service info. I do breeze through things and I focus in on the things that I feel are important to me to understand about the system. But if you read in the description operations for the auto HVAC system of this 13 Sienna, it says bus connector, air conditioning harness. It says a bus connector is used in the wire harness connection that connects the servo motor from the AC amplifier. Each bus connector has a built-in communication driver IC, which communicates with each servo motor connector, actuates the servo motor, and has a position detection function. This enables the bus communication for the servo motor wire harness for a more lightweight construction and reduced number of wires. And they show a diagram. Here's what it would be. They actually have a diagram in there. Here's what it would be if we had 5 wires running from every HVAC motor. And here's what it is when we just have the 3 that are daisy chained to each one. So that's why they did it. Now, I mean, there must be some sort of cost savings there, but they do explain it in the service info if you take the time to read it. So that's on me for not reading closely enough, or I might have looked at that sooner. So a harness fixed the communication issue. There was no communication getting from that LIN bus into the actual motor itself or to the connector because it was full of corrosion and the IC driver was dead. So harness fixed that. They did end up having to correct the passenger temp door position. They didn't clock it right. And again, it sounds like it's a huge pain in the ass to do that, but they were mostly concerned about the mode door, and the harness is what fixed that. So that was that one. That's all I got for that, but honestly, really crazy. And if you're listening to the audio version, make sure to go and check out the picture of this connector. It's pretty wild. Let me know if you guys have seen anything like this before or anything else, because this is the first one for me. And maybe if you're a Toyota tech, you've seen this before, right? It's 10 years old. But do they use this in other applications too? If not, are they going to start using this in different applications? I mean, definitely could. There's no reason they couldn't. And it adds a layer of complexity. But the first thing is just knowing that it is a thing. And well, now I do, and now you do. And hopefully if you run into this, you're more prepared. So that's what I've got for you today. I want to say thank you, everybody, for listening, watching the show. I really appreciate it. Keep up all the feedback. I definitely appreciate that as well. But with that all the way, let's get out there, start fixing the world one car at a time.